25 in Leetcode. The problem is reversing nodes in k groups. So essentially the problem is saying if let's say size n and you make a group of 2, if the k weighs 2, then you rotate them. So 1 2, it's gonna be 2 1, 3 4 becomes 4 3, and 5 doesn't have a group with the k size, so it's gonna be left out. And 1 2 3, if the k is 3, then 1 2 3 could be reversed, but 4 5 will stay out. Hopefully you get an idea about this. So I just submitted this problem, but I'm going to go through that and explain all over. So the problem is not that complicated. However, the main thing is the pointer management, because I made a few mistakes while maintaining the pointer, and then realized that part is not that trivial. So I just thought maybe I should make a video and ensure that people don't make a mistake like I did. So basically, before I get into that, I just wanted to call out that for linked list problem, typically what I follow is, let's say it's given, I always create a dummy pointer which is pointing to head, and let's say I'm calling it result list. So this is what's going to be. So you create a dummy pointer, set the next to the head, and this is head. And what happens is, in this mode, I always return the result list dot next as in my answer. So this is the pattern I follow. So I typically start pointing the next of result list pointer to the head, and somehow I do certain things, all the manipulation of the pointer, so that the tip of the end result always is pointed by the read list result list dot next. So I don't need to play around with result list dot head anymore, dot next anymore. I just set this and then return. But what I do is I create another pointer, let's call it result list iterator, and that's starting at result list, and I'm going to be moving this or changing this as I need to, as per the logic. So let me go back to the code. So these are the conditions. That's just going to avoid writing too many checks here and there. So the return list is the dummy pointer I was talking about, so it's going to point to the head because the next is set to that, and then I have a list iterator which is pointing to the return list. Now this basically keeps me ready so that I can write the logic without really worrying about null checks and other boundary conditions. So what I do is, when I start, I'm going to start with list iterator less than equal to null. It's going to be not null all the time to start with, because it's basically created with a dummy node, and the next is pointing to head. I already checked for head null and all, so those conditions would not really apply anymore, but yeah, it just makes the life easier here. So list iterator is not equal to null. So let's say I have a list like this, 1 2 3 4 5. Now I'm starting from here, as you see. So one more nice thing about this is, if I start from here, in the first iteration, when k is 0, I'm going to be on actually the first node. Second iteration, I'm going to be here. Third iteration here. So if the k was, let's say, given as 2, and I'm running a for loop to go to the second element after that, first iteration will take me here, second iteration will take me here. So you see how convenient that is. If I don't have any dummy pointer in the first loop, I'm going to be coming here. In the second, I'm going to be here. So I'll have to take the previous one of that by keeping another pointer. But this keeps the things easier. So I start from here, run a for loop, and till the time k is reaching to the value I want, it's going to be pointing to the exact element. Now I run a loop and figure out if I'm finding the kth node or not. So I'm also checking for the node not equals to null, and if I find it null, I could break it, and this is a valid check because I could see for the intended value of k, it's going to be intended element. So if if let's say I'm running a loop and k was set to 2 and it was just the one dot next was null, so k is 0 is going to be here, k1 is going to be 1 next is null, so it's going to fail. So then we surely know that we can return early on here. So this is what it is. So this is a good check. Now I found that there's a group of k, and if I did not find it, I could just break. Now what I can do is I'm going to basically, let's say I found group of 1 2 3 4, so my kth element is basically 2, right? And now I'm going to be I'll try to reverse. Now the problem with the reverse here is that, let's say I reverse and make it 2 to 1, so 2's pointer, the next pointer which is 3, that's going to be lost. 2 will start pointing to 1, and then head was pointing to 1, so there are a lot of references which are going to be lost if we don't keep track of that. So what we do is we try to reverse, but we're going to be keeping things in our back pocket to remember that for later. So previous, next, and cur. So 3 pointers. Cur is list iterated or next. So since we are starting from the leftmost, remember that, which is a dummy pointer. So we'll say that cur pointer is the next of the list iterator. So 1 is where my current would be. Now running a loop for k. So next is cur dot. So I would be here. Cur, the next one is 2, and cur dot next is cur is still at 1. So 1 dot next is going to be previous is null. So 1 will start pointing to null, and now previous will become null. Previous will become 1, and cur is going to be 2. Now running another loop, 2 will start pointing to 1, and we will also save cur in the next of 3, as you can see. And next is basically saving the next pointer is saving the value of 2. So basically what happens is at the last run of k, your next is basically 3, and your next is basically, your cur is going to be set to next value, which is 3, and prev is going to be equal to cur. So 2 is going to be pointed by prev, and 3 is going to be pointed by the cur element, so cur pointer. So this is important because, as you can see, the pointer 3, pointer pointing to 3 needs to be pointed by the reverse of this. So basically 2 should be at the top, pointed by the head of the list, and 1 should be pointing to 3, right? That's what it needs to happen. So what we'll do is at this point of time, we're just going to be saving list iterator next in a tail pointer, and list iterator next. List iterator has not moved yet. List iterator is still pointing to, list iterator was still pointing to this node. I think, yeah, this was actually this node. So list iterator is still pointing to this. Now let's see. We want to reverse 1 2. So 1, now 1 2. This has been reversed, right? And my list iterator dot next is still pointing to this 1. So, and now based on this information, I need to switch the pointer. So the next of this should be pointing to the cur, which is 3. So this is cur pointer. So I save the reference of this head 1 pointer, node 1 here, as you can see here. Say, and then tail is this pointer, say, and tail dot next is cur. So as you can see, tail dot next. So once it's pointing to 1, and 1 dot next should be pointing to cur here. So this should continue. So 2 1 and then I have 3. So 2 1 3, that takes care of that. And the list it.next is previous. So so now the head here should be pointing to 2, right? And then list it is going to be moving to the tail, which is so list it is going to be moving to tail, which is your 1 here. So basically what happened after this is this dummy is still intact and your result list is still that, and it's pointing to so we switch to 2 and then 1 and then you have 3 and 4, and what we did here was we moved our pointed to the list it pointed to tail, and tail, let's confirm what it is right now. So in this run list it.next was 1, so we will have 1 here. It's going to be pointing to